Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of application of derivatives. And if I talk about the question that we have here from this topic, the question tells us that for a differentiable function f which goes from 0 to infinity, where this function can be defined for any real value r, they have given us a condition that says f of x minus f of y is greater than or equals to natural log of x over y plus x minus y. And this is true for x and y, which can be anywhere from 0 to infinity. The question tells me to figure out the value of an expression which is summation of n is equals to 1 to 20 f dash of 1 over n squared. So that's the question asked to us. And if I talk about the answer choices that we have been given here, the options are 2890, 2390. The third answer choice we have been given is 1245. And the fourth one says none of this. So we need to figure out which one of the answer choices is the correct answer for this expression's value that is asked to us. Let's see how to solve this question further. So for solving this question further, what I can do here is I have been given f of x minus f of y is greater than or equals to natural log of x over y plus x minus y. So this natural log of x over y, which is given to us, I can just write that as natural log of x minus natural log of y plus x minus y. Now, once I have this, we'll just do certain manipulations because we want to find the derivative of this function f dash. Then we'll put whatever we get as 1 over n square. So what I will do is I'll just do a certain manipulation. Let's say instead of x, I'll put it as x plus h. And instead of y, I'll put it as x. So let's see how my function now changes. So my now new function would make it f of x plus h minus f of x greater than or equals to natural log of x plus h minus natural log of x plus x plus h minus x. So x and x cancels. I'm just left with plus h. So what I will do is I'll divide throughout by h everywhere. So what I'm left with is f of x plus h minus f of x over h greater than or equals to, this becomes natural log of e, x plus h minus natural log of e to the base x over h plus 1. Now if I just apply the limit h tends to 0 here to the whole left hand side and right hand side, what do I get is, if you guys know, the definition of the derivative of a function f dash of x is basically limit h tends to 0, f of x plus h minus f of x over h. So that same idea I'll be using it here. So this makes it f dash of x greater than or equals to, this limit is applied to this natural log function. So it will basically become derivative of natural log of x plus limit h tends to 0, 1, which is just 1. So I have this, and if I try to further solve this, I get f dash of x is greater than or equals to derivative of log x would be 1 over x. So 1 over x plus 1. Now here the problem is, I want to find summation of the values from n1 to 20 for the derivative of a function, but I want to just find for f dash of x. But here I have f dash of x is equal to 1 over x plus 1, that's okay. But if dash of x is also greater than 1 over x plus 1. So we are not sure of this whether f dash of x is greater than this expression or equals to this expression. I have both the conditions. So what I can do is to make sure about this whether it's equals to or greater than, I can do again a manipulation in the original part of the condition that was given to us, which was f of x minus f of y greater than or equals to this entire thing. So I'll write it again. I have f of x minus f of y greater than or equals to natural log of x to the base e minus natural log of y to the base e plus x minus y. So what I will do is I will basically multiply throughout by -1, both the sides. So when I multiply throughout by -1, my function would make it f of y minus f of x. This would get reversed. So natural log, or I can say less than or equals to, it will make it. This will become natural log of y to the base e minus natural log of x to the base e plus y minus x. Now here again, if I want to find the f dash of x, means the derivative of the function, I'll again try to frame it in the formula of this derivative in this form. So first part, I should have it as x plus h. So here I will substitute let y is x plus h and x will just put it as x. So this makes it f of x plus h minus f of x less than or equals to natural log of x plus h minus natural log of x plus x plus h minus x. So x and x cancels. Throughout again I'll divide by h everywhere. So h and h basically cancels and becomes 1. So I get from here f of x plus h minus f of x over h less than or equals to natural log of x plus h to the base e minus natural log of x to the base e over h plus 1. Now once I have this, I'll take the limit again on both sides where h tends to 0. Limit h tends to 0 here as well as here also. So what I get from here is again f dash of x, because that's the definition of that. So limit x tends to 0, this is entirely the definition of the function's derivative. So f dash of x less than or equals to f dash of natural log of x to the base e plus 1. So we know the derivative of a function, of a logarithmic function, is 1 over x. So we get this. So I'll mark this. This is, let's say, 1. This is 2. So here I'm getting that the derivative of function might be less than or equals to. But if you actually combine and see both the statements together, both of them jump to only one conclusion, that f dash of x is actually equals to 1 over x plus 1. So that's the case, and I want to find f dash of 1 over n square, not just f dash of x. So instead of x, I'll put 1 over n square. So that gives me 1 over n square, which is n square plus 1. Because that n square is in the denominator of the denominator. So when it's divided in the fractions flip. So the denominator fraction flips and gives me n square over 1, which makes it n square. So n square plus 1 is my f dash of 1 over n square. But the question is asking me to find the summation of that from n equals 1 to 20. So if I want to find the summation of n equals 1 to 20 for that function of 1 over n square, I'm just going to find the summation of n equals 1 to 20 for that n square plus 1. So what I can do is I can just split it. So we know summation of n square from 1 to 20. So summation of n square, we know it's n into 2n plus 1 into n plus 1 over 6. So n into n plus 1 into 2n plus 1 over 6. So here I can write that as 20 into 20 plus 1 into 2 times 20, which is 40 plus 1 over 6 plus summation of n equals 1 to 21, means 1 is added 20 times, which is just 20. If I try to cancel this 20, 21 and 41 over 6, so 3 2 times and 3 7 times, 2 1 times and 2 10 times. So you get 70 times 41, which is 2870 plus 20. So adding that gives me 2890. And if I see the answer choice that matches with this question is option A. So A becomes the correct answer choice for this question that was given to us here. I hope you have understood how to solve this type of questions. So first idea was we tried to convert it in terms of the definition of derivative using the first principle concept. We tried to convert it in this form for both the ideas. Once I got it that the derivative was greater than or equals to, the other time I got it, it was less than or equals to. So I got the idea that it's equals to. So once I got it equals to, I just found the value of the expression that was asked to me, and that basically matched with answer choice A. So A becomes the correct answer for this question that was given to us here. I hope you have understood how to solve this type of questions which deals with the ideas of using the concepts of derivatives. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE so they can also take the benefit from these questions that we are solving. Thank you.